Hi students, this is Alex here. Section A, question number 1. Sum of two skew symmetric matrices of same order is always. When we take example of two skew symmetric matrix and when you add and see, we always get a skew symmetric matrix as the answer. So the correct answer is option A. Question number 2, they have given a matrix A and they are asking A is. If we see the numbers present here, we find in the leading diagonal we have zeros and diagonally opposite elements have the opposite sign. So this is minus 3 and we have plus 3, and this is 8 and we have minus 8, and this is 5, we have minus 5. So it is a skew symmetric matrix. So the correct answer is option C. Next, question number 3, they have given a graph and they are asking the graph shown below depicts. So in the option we have cot, then cot inverse x, then tan inverse x. I have shown the graph given from the textbook. So it is a cot inverse graph which is present in the question number 3. So we can check from the diagram given in the NCERT. Y is cot inverse and we have a graph, and this present in the question number 3, so we choose the option B. Question number 4, they have given both A B dash and B dash A be defined for the matrices A and B. It means A B dash product is possible, at the same time B dash A product is also possible, and order of A is n rows and m column. So this is n rows and m column. So I write that here also. Then they want the order of B. Suppose if we multiply A with B dash, suppose if this is of the order x rows and y column, these two should be same, then only this multiplication is possible. So x should be m. Then we have b dash here, so again I take x rows and y column. Since this b dash a is defined, these two should be same. It means y equal to n. So b dash, which we assumed x rows and y column, is m rows and n column, but they want the order of B. So B and B transpose will have rows and columns interchange. So this will be n rows, that is B will have n rows and m column. So from the option we choose option B. Question number 5. They have given a function and they say it is continuous at x equal to 0. And when x is not equal to 0, both left hand limit and right hand limit, we take the same function. Let's take the left hand limit where we take f of x and we use limit x tending to 0 minus, and we choose this function log of 1 plus ax plus log of 1 minus bx. We have whole division by x. Let's take it as an individual division. Now we are going to apply a formula, that is when we have log of 1 plus x whole divided by x, when limit x tends to 0, this value is 1. So I have to multiply a and a here so that this entire term is 1 according to this formula. In the same way, I have to multiply minus b here and minus b so that I have log of 1 minus bx by minus bx, because when you apply the formula, when there is x, we should have x in the denominator. So minus bx, we need minus bx. Here ax, so this is ax. So after making this as 1, we get a minus b. And since it is continuous at x equal to 0, the value of k is a minus b, which is present in the option C. Question number 6, they have given y equal to a cos of log x plus b sin of log x, and they want the value of this. Let's find its derivative y1, which is a into minus sin of log x into 1 by x plus b into cos of log x into 1 by x. We take 1 by x common and we carry to the other side, so it is y dash into x, and this is minus a sin of log x plus b cos of log x. Now we have to use product rule. X differentiation is 1 and we keep y dash as it is, plus x we keep as it is, y dash y1 differentiation is y2, and here it is minus a cos of log x into 1 by x plus b into minus sin of log x into 1 by x. Again we take x common, that is 1 by x common, and carry here x into y dash plus x y2, which is equal to, after taking minus common, we have a cos of log x plus b sin of log x. Now this is actually from the question, it is y and we have minus y here, and this after multiplication xy1 plus x square y2. So they are asking x square y2 plus xy1, which is here, and that is actually minus y. So the option C is correct. Question number 7. We have secant inverse minus root 2. If we take minus outside, this will become pi minus of secant inverse root 2, then minus tan inverse 1 by root 3. So now this becomes pi minus, this is pi by 4, and this is pi by 6. So we can take LCM, which is 12, and this is 12 minus 3, 12 pi minus 3 pi minus 2 pi. So it is actually 12 minus 5, which is 7 pi by 12, which is present in the option D. Question number 8. They have given tan inverse of x square minus y square equal to a, and we have to find dy by dx. So let's take this tan inverse to the other side. So we get x square minus y square equal to tan a. Tan a is a constant. When we differentiate, this is 2x minus 2y dy by dx equal to 0. We can take this to the other side. So 2x equal to 2y dy by dx, and 2y we can bring it here. So 2x by 2y is our dy by dx. After cancelling this, we get x by y, which is present in the option A. Question number 9. They have given f of x as x square and x belong to R, and they are asking which of the following is incorrect. If I take f of x as y, and when y is x square, it is the upward parabola. So we can draw like this. From this parabola, we can answer this question. Option A, minimum value of the f does not exist. Actually, this parabola minimum value is here, which is 0. So they are asking which is incorrect, and this is the incorrect statement, and that is the option A is the correct answer for this question. If you want to check why the other options are wrong, option B, there is no point of maximum. Actually, the parabola is extending on both the sides, so there is no maximum. It is having only minimum. So this is actually a correct statement. F is continuous. Yeah, it is continuous. There is no break in the curve, and it is also differentiable. So the only incorrect statement is option A, which is the minimum value of f does not exist, but actually the truth is the minimum value exists and it is 0. Question number 10. We have integral of x plus 5 by x plus 6 whole square into e power x dx. We are going to rewrite this. E power x, we have x plus 5. Let's write it as x plus 6 minus 1, and next we have x plus 6 whole square. So we are going to divide it individually, so that this is integral e power x, and this becomes x plus 6 by x plus 6 whole square and minus 1 by x plus 6 whole square, and we have dx. After cancelling this, we have 1 by x plus 6. If I take this as f of x, and this will become f dash of x, and we have a form e power x into f of x plus f dash of x. The answer is e power x into f of x plus c. So here the answer is e power x into 1 by x plus 6 plus c. So from the given option, we find the option present in the option C. Question number 11. They have given f dash of x and they are asking f of x, and they gave one condition. To find f of x from the f dash of x, we have to integrate f dash of x, and this is with respect to x. So the first term 3 we keep as it is, x square plus 2x. X square is x cube by 3, 2x is x square by 2. This is actually x power minus 3 when I carry up. So when I have x power minus 3 on integration, this will be x power minus 2 by minus 2. So already there is minus 4, and we bring this x power minus 2 down. So 1 by minus 2x square, and at the end we have the constant 5, so that is 5x, and we have to put a constant c. This 3 we can multiply inside, so we get x cube. After cancelling this, we get 3x square, and we can cancel this and make it as plus, and also we can cancel this, so this is plus 2 by x square plus 5x, then plus c. So we got f of x, but we find x cube plus 3x square here, the plus 2x square, then plus 5x. So this option and this option has same thing, only the value of c is different. So we are going to find that using this condition f of 1 equal to 0. So it means we have to put x as 1. So this is 1 plus 3 plus, when I put 1 here, this is 2 plus 5 plus c. So adding this together, we get this is 4, 6, 11, and this value is 0 because f of 1 is 0. So c is minus 11. So from the given option, minus 11 present here. So the correct answer is option B. Question number 12, they want the order and degree. So the highest derivative present here is the second order. So order is 2. But this derivative present inside the log, it means the degree is not defined. So from the given option, the order is 2 and the degree is not defined. So the derivative should not present inside the sine, cos, log or exponential function. So here we have derivative inside the log, so degree is not defined. So order is 2, degree is not defined, option C. Question number 13, they have given a graph, they have given z which is x plus 2y, they gave all the feasible region PQRS with the points here, and they are asking which of the following is correct. So here in the option we find everything is the value of z, everything is based on the value of z. So let's find the value of z at each point. So let's take the point P and substitute in z. So I take it as ZP. So 13 we have in the denominator. So 3 by 13 plus 2y. So 2 into 24, which is 48 by 13. So it is 51 by 13. 52 by 13 is 4. So this is roughly 3.9 something. Now Z at Q is 3 by 2 plus 2 into 15 by 4. That is 15 by 2. So this is 18 by 2, which is 9. Then Z at R is 7 by 2 plus 2 into 3 by 4, which is 3 by 2, 10 by 2, which is 5. And Z at S is 18 by 7 plus 2 into 2 by 7, which is 4 by 7. So 22 by 7, which is roughly 3 point something. Now let's see the options. Z is minimum at S. So that is not true because, sorry, that is actually true because 3 is the minimum of all the values. This is 3.9, this is 9, 5. So we notice this is correct. Let's cross check whether the other options are wrong or not. That is maximum at R. That is not true because maximum is at Q. So this is wrong. Then at P is greater than at Q. So at P is 3.9, Q is 9. So at P is not greater than at Q. So this is wrong. Then at Q is less than R. So at Q is 9 and at R is 5 and Q is not less than R. So this is also not correct. So the correct is option A, which is that is minimum at S and the minimum value is 3 point something. Question number 14. They want the area of the region bounded by the curve, which is y square equal to x. So if we draw the rough diagram, x axis, y axis, and it is a parabola which is opened on the right side. They say between x equal to 0 and x equal to 1. X equal to 1 is this and x equal to 0 is here. So 0, 0 and 1, 0. It means they want this full area. We calculate the area of the first quadrant and we put into 2. Limit is from 0 to 1. Y from the given curve is root x dx. So when I integrate, this is x power half. So when I integrate x power 3 by 2 by 3 by 2, so we take into 2 by 3 here and we have a limit from 0 to 1. Using the upper limit we get 1. So 4 by 3 into 1 is 4 by 3. Lower limit it is 0. So from the options, it is option D. 4 by 3 square units. Question number 15. They have given a vector magnitude which is 5 and lambda which is ranging from -2 to 1. They want the range of lambda a vector magnitude. So when I take the lambda value as -2, so we have lambda a vector magnitude. So when I take lambda outside and we have a vector, and this will be, if I take -2 into 5, we are getting -10. In the same way, if I use 1, then this will become 1 into 5, which is 5. So actually we are getting -10 till 5. But this is entire magnitude is always going to be positive. So if I have 0 here, all this negative value will be a positive value. So we have a range from 0 till 10. But this option is not given. So maybe the marks will be given for attempting the question. Question number 16. They want the solution for the given differential equation. When I remove log, we get dy by dx, and on the other side it will become e power 3x plus 4y. So we are going to rewrite this as dy by dx as e power 3x into e power minus 4y. We have to do variable separable. So dy by e power 4y equal to e power 3x dx. And we have to integrate this. When this goes up, this is e power minus 4y. On integration, we get e power minus 4y by minus 4. And this is e power 3x by 3 plus c. So in the option we find all the terms are on one side. So it is better we take this term to the other side. So it is 1 by 4 e power minus 4y plus 1 by 3 e power 3x plus c equal to 0. By taking LCM we get whole division 12. This is 3 e power minus 4y plus 4 e power 3x plus 12c equal to 0. By cross multiplication 0 to 12 becomes 0, and this we find in the option D, 3 into e power minus 4y plus 4 into e power 3x plus 12c. So the term we got it in the option D. In question number 17, they have given a graph and there is a function z which is 2x plus 5y, and all the equations are given and the diagram is also plotted. They are asking to study the graph and select the correct option. Now we see the shaded region is lying this way for this line and this way for the another line. There is no common shaded region, and if you see the option, they have given the solution lies in the shaded unbounded region. That is not true because we need a common region. Lies in the triangle AOB. Even that is not true because we have a shaded region here, and it does not exist is the true because there is no common region. It means there is no solution. And we cannot take the last option because it lies in the combined region, because we need a common region. We cannot take a combined region. They have given the combined region of triangle AOB and unbounded shaded region, but the solution is always the commonly shaded region and which does not present in the graph. So the solution of the given LPP does not exist. Question number 18, they have given the chances that 3 persons A, B and C go to the market are 30, 60 and 50%. The probability that at least one will go to the market. So probability of at least one will go to the market is 1 minus probability of none goes to the market. So it means 1 minus P of A dash into P of B dash into P of C dash, which is 1 minus A goes to the market is 30%, so does not go is 70%, and B go to the market 60, does not go is 40, and C goes to the market 50, does not go is 50. So now we are going to simplify this. Actually we can reduce this 0, 0, 0 and 0, and this is actually 1 by 2, and even this we can cancel, this will become 2. So totally 1 minus, we have 7 into 2 by 10 into 10. Even we can cancel this 5 times. So this is 1 minus 7 by 50. By taking LCM, we get 50 minus 7, which is 43 by 50, and which is present in the option B. Question number 19. In assertion, they have given magnitude of A cross B square plus magnitude of A dot B square is 256. They gave magnitude of B as 8. Then they say magnitude of A is 2. So we have a formula that is mod A square mod B square. That is mod A vector mod B vector whole square is A cross B magnitude square plus A dot B magnitude square. So this can be got by taking the value, that is formula for A cross B, which is mod A mod B sin theta, and A dot B is mod A mod B cos theta. We can derive this one. So now check with all these values. They say this is 256, and on the other side mod A square, which is 2, so 2 square which is 4, and mod b is 8, so 8 square is 64. So when I multiply this, I am getting 256. So this assertion is true. And sin square theta plus cos square theta equal to 1, and using all these formulas only we are getting this. So this is also true and it is the correct explanation. So option A. Now question number 20, they have given two functions, f of x which is e power x, g of x which is log x, and f plus g is the sum of this e power x plus log x, where domain of f plus g is R they have given. Actually, for e power x, x can take any value from minus infinity till infinity, but log x can take only from 0 to infinity. Even 0 is not included, so from within, that is from 0 to infinity. So when we see the domain of these two, we cannot say R, because inside log we can have only from 0 to infinity, not negative numbers, that is less than 0. So it means this is false. And this is anyway true, because when I take domain and we take the intersection of both the intervals, and this is true. So the correct option is, from these options we choose A is false but R is true. Next part, section B, question number 21, and we have our choice. So let's take the A. We are going to differentiate this with respect to this. We take u as root of e power root of 2x and v as e power root of 2x. Now du by dx will be 1 by 2 root of e power root 2x. Then again differentiation of e power is e power, the whole thing will come as it is, then into this power we have to differentiate again. Root of 2x is 1 by root of 2x, that is 1 by 2 root of 2x. Then again this differentiation will be 2. Then coming to the next part, we have to find dv by dx, which is 1 by, we have e power root 2x, so this is e power root 2x, then differentiation of root 2x is 1 by 2 root 2x, then differentiation of 2x is 2. So to get du by dv, we have to divide this entire thing by dv by dx. So here we can cancel these two, then e power root of 2x whole divided by 2 root e power root 2x and root 2x. We are going to divide by this, so here we can cancel this one. When I divide, I can take the reciprocal, so root 2x by e power root 2x. So here whatever possible we can cancel, and after cancelling the left out term is 1 by 2 root e power root 2x. So this is our du by dv. Now coming to our question, that is x power y equal to y power x. Now they want dy by dx. Let's do it here. X power y equal to y power x. So for this we need to take log on both the sides. So when I take log, it is log x power y equal to log y power x. Using power rule, y log x equal to x log y, and you have to use product rule. Differentiation of y is dy by dx, log x we keep as it is, plus y we kept as it is, and log x is 1 by x. Other side again product rule, x differentiation is 1, log y we keep as it is, and x we keep as it is. Log y differentiation is 1 by y dy by dx. Now by grouping the dy by dx term to one side, we get dy by dx into log x minus x by y into dy by dx, and on the other side it is log y minus y by x. Now we are going to take dy by dx common, so which is log x minus x by y, and this will be log y minus y by x. So this entire term will go to the denominator of the other side. So we get dy by dx equal to log y minus y by x, then whole division log x minus x by y. If you want, we can take LCM. So this will be x log y minus y whole division by y. Then here the LCM is y. So y log x minus x. Then this will be rewritten as log, actually x log y. So we take x log y minus y by x into y by y log x minus x, and finally rearranging we get y by x, x log y minus y by y log x minus x. This is our required dy by dx. Now question number 22, A part. They have given A and B are the position vectors of point A and B. The position vector C on BA produced such that BC equal to 3BA. Now let's take A here and B here. This is O. So now when I take this as position vector small a vector as per given in the question, and this is small b vector. If a vector and b vector are the position vectors of point A and B, find the position vector of C on BA produced. When it is said BA produced, from here we extend this and C is here, and we have to find this OC vector. So from here, this OC vector we have to find, and they also gave condition BC is 3BA. The entire line is BC, which is 3 times of BA. So when this is X and this AC is 2X, then this condition is satisfied. That is, BC is totally, by taking from B to C, it is 3X, and BA is X. This can be done in two ways, and I will use one such way that I take this as C vector, and as per the question it is given, it is the externally dividing, but I am going to use internally dividing, that is OC and OB we have, and OA is dividing internally in the ratio 2:1. So according to the diagram, OA vector equal to, formula is MOB vector plus NOC vector by M plus N. So even though as per the question is given externally dividing, by considering the diagram, I am taking OA, and OA is between B and C. So now this is the ratio 2:1 because 2x and 1x. So M is to N is 2:1. So now we take, this is A vector equal to MOB, which is small b vector, plus N, which is 1, OC, that is c vector whole division 2 plus 1, which is 3. Since they want the position vector c, we have to find the position vector c. So from this we can cross multiply and get this is 3a vector equal to 2b vector plus c vector, and finally c vector is 3a vector minus 2b vector. Even if we use the externally dividing formula, still we get the same answer. Next, B part of the question, we have vector r vector is inclined at equal angles to the 3 axis xyz, and the magnitude of r is 5 root 3 units. Then we have to find the r vector. When they say equal angles, so we have a relationship between the direction cosines cos square alpha plus cos square beta plus cos square gamma equal to 1, and they have given equal angle, so alpha equal to beta equal to gamma. So all these things we can change into alpha itself. So cos square alpha plus cos square alpha plus cos square alpha, so which is 3 cos square alpha is 1, and cos square alpha is 1 by 3, and cos alpha is plus or minus 1 by root 3. It means all the three values, cos alpha is plus or minus 1 by root 3, then cos beta is plus or minus 1 by root 3, and cos gamma is plus or minus 1 by root 3. Now using this we can frame the unit vector r cap, which is cos alpha I cap plus cos beta j cap plus cos gamma k cap. So this will be plus or minus 1 by root 3 I cap plus or minus 1 by root 3 j cap plus or minus 1 by root 3 k cap. And since the vector r vector is having 5 root 3 as the magnitude, we will multiply 5 root 3 with this unit vector, and that will be our r vector. And here we can take plus or minus 1 by root 3 common. We left with I plus j plus k. So anyway we can cancel this, and finally this is plus or minus 5 into I cap plus j cap plus k cap, and this is our required r vector with magnitude 5 root 3, and it is equally inclined with the xyz axis. Question number 23, they have given determine those values of x for which the given function is increasing or decreasing. So the first part, we find f dash of x, which is minus 2 by x square. And if I take a number line from minus infinity to plus infinity, any value if I choose and substitute in place of x, the denominator is going to be positive, but ultimately there is a minus sign. So this f dash of x is always less than 0. So it means f of x is decreasing on minus infinity comma infinity, and 0 is not included because already they have given x is not equal to 0. Either we can give the answer like this, or minus infinity comma 0 union 0 comma infinity. So in these values the function is decreasing. Question 24, we have to find the domain of the given function f of x, which is sine inverse of minus x square. So this minus x square lies between minus 1 and 1. Now we take this part alone, which is minus 1 less than or equal to minus x square, and we take this part alone, minus x square less than or equal to 1. Actually, this x square, if I take this minus to the other side, x square is negative, which is not possible. So we ignore this equation and we take this one. Taking x square here, we get x square less than or equal to, and this minus 1 comes to the other side, which is 1. When we have x square is equal to 1 and the value of x is plus or minus 1, we take a number line from minus infinity to plus infinity, then this is minus 1 to 1. The value of x which satisfies this equation is from here. If I take any value like 2, 2 square is less than 1, which is not true. Same thing happens here. If I take minus 2, this won't satisfy. The only region which satisfies is minus 1 comma 1 for this equation. So this is our domain. Question number 25. They want the value of lambda for which the given lines are perpendicular. Now from the first equation we take this minus sign common, and that will be carried to the denominator. So this is x minus 1 by 3. Similarly, this 3 is taken common, it will be carried to the denominator of the denominator. So this will be y minus 2 by 3 by 2 lambda by 3, and this is already in the proper form, so we take like this. So here this is our a1, b1, c1. In the same way, from the line 2, it is x minus 1 by 3 lambda equal to, taking minus sign common, we get y minus 1, and the minus is carried to the denominator, so it is minus 1. And now taking 2 common, it is z minus 5 by 2, and this 2 will come to the denominator of the denominator, which is 3 by 2. And this is a2, b2 and c2. Since the lines are perpendicular, we use a perpendicular condition, a1 a2 plus b1 b2 plus c1 c2 equal to 0. So 3 into 3 lambda plus 2 lambda by 3 into minus 1 plus 3 into 3 by 2 equal to 0. Now totally this is 9 lambda minus 2 lambda by 3 plus 9 by 2 equal to 0. Now taking this 9 by 2 to the other side, we get minus 9 by 2. Here we take LCM, which is 27 lambda minus 2 lambda. So 25 lambda by 3 equal to minus 9 by 2. Then lambda will be minus 9 by 2 into 3 by 25. So lambda is minus 27 by 50. Next part is section C. Question number 26. They have given 3 matrices and they want the value of ABC. So first we take ABC and we multiply the matrix 1 minus 1 0 A, and B is 2 0 1 minus 1 3 4 0 5 1, and C is 2 3 4. Now let's multiply B and C first. So this entire row we take and multiply with the entire column corresponding elements. So first we keep A matrix as it is, then here 2 into 2 4 plus 0 plus 4. Then the same way second row, minus 2 plus 9 plus 16. Third row, 0 plus 15 plus 4. So finally we get 1 minus 1 0, the matrix A is kept as it is, and this is 8, and minus 2 plus 9 is 7, and 16 plus 7 is 23, and this is 19. Now we are going to multiply these two. So once again we take the first row and multiply the full column with corresponding elements, and that will be 8 minus 23 plus 0, which we get minus 15, and this is in the matrix, and we get one element minus 15. Question number 27, they have given the linear programming problem where z, the objective function, is given, z is x plus 4y, and we have to minimize and subject to the constraint, and we are going to take points for the first equation, which is 2x plus y. Let us take equal to 1000. We take x and y, and x is 0, y is 1000. When y is 0, x is 1000 by 2, which is 500. So we have 2 points to plot this line. Similarly, x plus 2y equal to 800. When x is 0, y will be 400. When y is 0, x will be 800. So we have 2 points here. And we have to draw the graph. So I am going to take a rough graph here. This is our x-axis. So I draw it little bigger so that we can able to find or visualize the solution in the rough graph. This is our x-axis and y-axis. But here there is another set of constraint, which is x and y are greater than 0. So we will be using only the first quadrant. The maximum value is 1000. So we can go for taking the scale. Before that, let's mark this as x, x dash, y, and y dash. So we take, this is 0, this is 1, 2, 3, 4, 5, 6, 7, 8. Actually, the maximum value of x is 8, and for y it is 1000. So we have to use the scale accordingly. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So now let's plot the lines. So 0, 1000, and that will be here. And let's write all the values also in the graph. I'm going to take 100 units. So 100, 200. So let's finish this. 300, 400, 500, 600, 700, 800. And even here it is 100, 200, 300, 400, 500, 600, 700, 800, 900, 1000. So now 0, 1000 and 500, 0. So this line we are going to join like this. Then the second line we have 0, 400 will be here, and 800, 0 will be somewhere here. So this will be here. Now put arrow for this, and both having the inequality greater than 0. It means we have to shade the region which is away from the origin. So basically all these regions we have to shade. Now this meeting point from the graph it is roughly seen as 400, 200. And our corner points, feasible points are this point, which is 0, 1000, and let's take this as A, this as B, and this as C, which is 800, 0. After this, we have to calculate the value of Z, x plus 4y. So carefully we have to write the scale in the graph, which is in x and y axis 1 centimeter is equal to 100 units. So let's take the point A. So Z is equal to x plus 4y. So we are going to calculate x plus 4y for point A. So ZA, x is 0 and 4 into 1000, which is 4000. Then coming to point B, ZB, which is 400 plus 4 into 200. So this is 400 plus 800, we get 1200. Then 800, 0, which is ZC. So 800, since y is 0, totally this is 800. So we are getting the minimum value as 800, but we have to check whether is this the only point or we have any other minimum value. So for that we have to use Z as 800 in the Z equation, that is our Z is x plus 4y. Let's take this as 800. We have to plot this in the diagram. So we have x and y. When x is 0, y is 200, because by dividing by 4. When y is 0, this is 800. We are going to plot this line 0, 200. I plot it here. 0, 200 is here, and then 800, 0. 800, 0 is here. So when I try to plot this Z, it is correctly passing through this solution 800, but it does not go inside the shaded region. It means this is the only minimum solution. Therefore, only minimum value equal to 800 at the point C is 800, 0. So at 800, 0. Question number 28, A part. We have the question in which we have to find the distance of the point from the line. We take a small diagram, that is, we have a line and we have a point P, which is 2, 4, -1, and we have to find the distance between point and the line. It is always a perpendicular distance. So let us take this point as Q, which is nothing but the foot of the perpendicular. After finding this Q, we can find the distance. First we have to equate this line to K. X plus 5 by 1 equal to y plus 3 by 4 equal to z minus 6 by minus 9 equal to K. Equating individually, x will be K minus 5, y will be 4K minus 3, and z will be minus 9K plus 6. So this Q is K minus 5, 4K minus 3, minus 9K plus 6. Now we take dr of the line PQ, which is the difference. So K minus 5 minus 2, which is K minus 7. then 4k minus 3 minus 4, which is 4k minus 7, then minus 9k plus 6 minus 1 minus 1 plus 7. So we got dr. And now dr of the given line, let us take the given line as AB, which is here 1, 4 and minus 9. So dr of AB is 1, 4, minus 9. Since these two are perpendicular, we are going to use the perpendicular condition, that is A1, A2 plus B1, B2 plus C1, C2 equal to 0 using perpendicular condition. Now this is k minus 7 into 1 is k minus 7 plus 4 into 4k minus 7, which is 16k minus 28, then minus 9 into minus 9 is plus 81k minus 63 equal to 0. Now k, 16k and 81k added together, we get 81 plus 16 plus 1, 17. So this is 98. So 98. And now this is minus 7, minus 28 and 63. By taking this to the other side, this is 98k equal to 7 plus 28 plus 63. So 28, 7, 63, 10, 18, and we get here 98. So it means k is 1. 98 by 91, k is 1. After getting k, we can get the actual point q. So our q will be, if I put k as 1 here, this is minus 4. When I put 1 here, 4 minus 3 is 1. When I put 1 here, minus 9 plus 6 is minus 3. So now we have p and q. So let's write it here once again. P is the one which is given in the question, which is 2, 4, minus 1. 2, 4, minus 1. And q, which we got it just now, minus 4, 1, minus 3. Minus 4, 1, minus 3. Now, using the distance formula, PQ, which is root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus or minus plus whole square. So totally this is minus 6 whole square, which is 36. This is minus 3 whole square, which is 9. This is minus 2 whole square, which is 4. So this is root 49, which is 7 units. This is the distance between the point and the given line. Next, our question B part, we have given the position vectors of point A, B and C. So we take OA vector, which is the first one, 3i minus j minus 2k, OB, the second point as a B vector, OB vector, that is I plus 2j minus k, and OC vector is I plus 5j plus 3k. Now we have to find the vector and the Cartesian equation of the line passing through A and parallel to BC. So dr of BC is the difference, that is point C minus point B. So it is 1 minus 1, which is 0, then 5 minus 2, which is 3, then 3 minus or minus 1, which is 4. And now the passing through point is A, so that can be taken as A vector 3i cap minus j minus 2k, and direction ratios are taken as B vector, which is 0i plus 3j plus 4k, and the vector equation of the line is r vector equal to A vector plus lambda B vector. So r vector is 3i cap minus j cap minus 2k cap, which is the passing through point A, then plus lambda times of the dr, which is 0 I cap plus 3 j cap plus 4 k cap. And our Cartesian equation is, this is vector equation, and Cartesian equation is x minus 3 by 0 equal to y plus 1 by 3 equal to z plus 2 by 4. Question number 29, A part, you have to differentiate the given function with respect to x. Now we take the substitution x is equal to sine theta, so y becomes sine inverse of 3 sine theta minus 4 sine cube theta, which is actually sine 3 theta. So we get sine inverse of sine 3 theta, and y becomes 3 theta. And from this we are going to replace theta, which is sine inverse x. So we have y equal to 3 sine inverse x. So its differentiation with respect to x dy by dx is 3 into 1 by root 1 minus x square, which is 3 by root 1 minus x square. Next, our question, the B part, we have to differentiate y with respect to x. So here we take x as tan theta, so y becomes cos inverse of 1 minus tan square theta by 1 plus tan square theta, and this entire term becomes cos 2 theta, and now y becomes 2 theta. We are going to replace theta from here. From here theta is tan inverse x. So 2 tan inverse x. So from here we differentiate dy by dx, which is 2 into 1 by 1 plus x square. So it is 2 by 1 plus x square. Question number 30, A part. A student wants to pair up natural numbers in such a way that it's satisfying this equation, where both x and y belong to natural number. We have to find the domain, range, and we have to check if the relation is reflexive, symmetric and transitive, and we have to state it is equivalence or not. From the given equation, let's write y equal to 41 minus 2x. Suppose if I take x as 1, if I put 1, we get y as 41 minus 2, which is 39. If I take x as 2, then y will be 41 minus 4, which is 37. So in the same way, if I keep putting the values, we get, when x is 20, y will be 41 minus 2 into 20, which is 40, so totally it is 1. I cannot put more than 20 because y will become negative. It is given x and y belong to the natural number. So we are getting a relation as an ordered pair 1, 39. 2, we have to keep decreasing to 2 values, 37. Then 3, 35. 4, 33. 5, 31. 6, 29. 7, 27. 8, 25. 9, 23. 10, 21. 11, 19. Then 12, 17. And 13, 15. 14, 13. 15, 11. Then 16, 9, then 17 comma 7, 18 comma 5, 19 comma 3, 20 comma 1. So this is our relation because it is paired up. Now from this we can find the domain, which is all the first value, which is x value. So we can say domain, you have to write it as a set 1, 2, 3 dot 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 till 20. Second part, they ask range of the relation. So all the second values I have to write. So range is, even we can start from the 1 also, 1, 3, 5, 7 dot 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 till 39. Now we have to check it is reflexive. When we have 1 comma 39, we should also have 1 comma 1, but that is not present in the relation. So 1 comma 1 does not belong to R, so it is not reflexive. And for symmetry, if I take 1 comma 39, but there is no 39 comma 1 in the relation, so 1 comma 39 belong to R, but 39 comma 1 does not belong to R, so it is not symmetric. Now I have to take for transitive. Suppose if I take 16 comma 9, then 9 comma 23. Let's write that first. I'm going to take 16 comma, I can take any examples, whatever is possible. So 16 comma 9 belong to R and 9 comma 23 belong to R. But if I check for the first and last element, that is 16 and 23, we don't have any pair as such 16 comma 23 in the relation, so it does not belong to R. So it is not transitive and hence it is not equivalence relation. Next, the odd part, we have to show the given function is bijective, it means 1 to 1 and on to. So let's take 1 to 1. For this, we have to assume cases. Let's take case 1 where n1 and n2 both are even. So f of x1, we take n1, f of n1 equal to f of n2. So we have to choose both even. The first function, it is n1 minus 1 equal to n2 minus 1. So we get n1 equal to n2. Now case 2, I have to take n1 and n2 are odd. So f of n1 equal to f of n2, we take n1 plus 1 equal to n2 plus 1. From this I am getting n1 equal to n2. Then we take case 3, n1 is even and n2 is odd. So when I take f of n1 equal to f of n2, when it is even, it is n1 minus 1. When it is odd, it is n2 plus 1. So we get n1 minus n2 equal to 2. Similarly, in case 4, n1 is odd and n2 is even. So when I take f of n1 equal to f of n2, it is odd. So n1 plus 1 equal to n2 minus 1. So n1 minus n2 equal to minus 2. So here we notice n1 minus n2, which is nothing but one is odd and another is even. So the difference we are getting as even here. One is odd and another is even. n1 minus n2 is the difference between odd and even, which is I am getting even. So which is not possible. So case 3 and 4 are invalid because difference between even and odd cannot be even. So these two cases are rejected. Now from case 1 and 2 we get n1 equal to n2. So we can conclude from case 1 and 2 it is 1 to 1. From case 1 and 2 it is 1 to 1. Then coming to on 2, we again take two cases. Let's take n is, the first case is actually even. So let us take n equal to even. So y equal to, y is nothing but f of x, which is n minus 1. From this n is y plus 1. When we go for arrow diagram, we have natural number and we have natural number here. So we take the even case, we take n and that becomes n minus 1. When I take this as y and this become y plus 1. And n minus 1, this becomes odd. So any odd number is of the form 2r plus 1. So this will be 2r plus 2. So we can say the pre-image exists. So in this case, pre-image exists. If you want to state clearly, we can say for every 2r plus 1 odd in codomain, there exists a pre-image 2r plus 2 in domain. In the same way, we can do for the case 2, when n is odd, it means y is n plus 1, so n is y minus 1. So we go for arrow diagram where we have natural number and we have natural number here, and this is n plus 1, and this is y, and this will become y minus 1. Since this is odd and this is even number is in the form of 2r and this is 2r minus 1. So here also we can say for every 2r there is a pre-image 2r minus 1. So we can say pre-image exists. So from this we can conclude it is onto. Since it is 1 to 1 and onto, it is bijective. So we can see from the question they say show that the given function is bijection. So bijection or bijective both are same. So we have to prove it is 1 to 1 and onto. Question number 31. They have given a coin is biased so that the head is 3 times as likely to occur as tail. So if there is one tail, then head is likely to occur 3 times. It means the probability of getting head is 3 out of 4 and probability of tail is 1 out of 4 from this given. And the coin is tossed 3 times and we have to find the distribution of the tails. So since it is tossed 3 times, the random variables are 0, 1, 2, 3, P of x equal to 0 means 0 success, that is 0 tail. So P of h into P of h into P of h, all are head, all the three are heads. So it is 3 by 4 into 3 by 4 into 3 by 4, which is 27 by 64. Now P of x equal to 1 means one tail and other two are heads. But this will come in the cyclic order. So out of three places, one is different. So we have to put into 3C1. This is 1 by 4 into 3 by 4 into 3 by 4 into 3, which is once again 27 by 64. Now P of x equal to 2. There are two tails and one head, and we have to put into 3C2 because out of three places there are two tails. So it will come in a different orders. So for including the order, we have to put 3C2. This is 4. 3C2 is 3. So this is 9 by 64. Finally, we have P of x equal to 3. It means all the three are tails. So P of t into P of t into P of t, which is 1 by 4 into 1 by 4 into 1 by 4, which is 1 by 64. So we are going to write this in a table where we have x and P of x. X is 0, 1, 2, 3. This is 27 by 64. This is 27 by 64. And this is 9 by 64. And this is 1 by 64. And we have to check by adding all this probability values from the distribution table. We have to get 1. So actually we are getting it because 27 plus 27 is 54. 9 plus 1 is 10. So 54 plus 10 is 64. 64 by 64 we get 1. It means this table is correct. Now we have to find the mean. So for finding mean, it is E of x, which is sigma xi pi. So 0 into 27 by 64 is 0. 1 into 27 by 64 is 27 by 64. 2 into 9 by 64 is 18 by 64. 3 into 1 by 64 is 3 by 64. So by adding 27, 18 and 3, actually this will be 8, then 1, 48 by 64. You can cancel with 16 table, which is 3 by 4. Next, section D, we have question number 32. Solve the differential equation. So by seeing this powers, we can understand it is a homogeneous. So let's take x square y dx equal to this entire term to the other side, x cube plus y cube into dy. Now I want dy by dx form. So this entire term will go to the denominator. So x square y by x cube plus y cube. Now let's take y equal to vx and dy by dx equal to v plus x into dv by dx. So this is v plus x into dv by dx equal to x square into vx whole division x cube plus v cube x cube. So from this we can write x cube into v, and from this we can take x cube common. So 1 plus v square, 1 plus v cube. Now we have x dv by dx. We can cancel these two, and this v we can take to the other side. So already we have v by 1 plus v cube minus v. We are going to take LCM, which is 1 plus v cube, v minus v into 1 plus v cube. So totally this is x dv by dx equal to v minus v power 4 by 1 plus v cube. After cancelling this, we can do the variable separable, that is 1 plus v cube into dv by v power 4. I keep the minus sign here itself, and dx by x, and we have to integrate on both the sides. Now we can individually divide this. Integral 1 by v power 4 plus 1 by v, that is v cube by v power 4 is 1 by v dv. This is minus integral dx by x. When I integrate this, this is v power 4. After integration, v power minus 3 by minus 3, and this is log v, and this is log x plus c. If you want, we can combine this, and v can be taken to the denominator. So minus 1 by 3v cube plus log. When I bring here, log v plus log x is log vx using the log rule, and other side we have only c. Now this is minus 1 by 3. V is from our substitution, we took y equal to vx. So v is y by x. So this is y cube by x cube, that x cube can be taken to the numerator, plus log y equal to c. And we got the solution. There is no condition given to find c, so we can leave the answer as it is. Coming to our question, solve the differential equation. So this is the first order linear differential equation. We divide every term by 1 plus x square. So it will become dy by dx, and this becomes 2x by 1 plus x square into y, and this we take to the other side. So 4x square by 1 plus x square. Now p is the term with y, which is 2x by 1 plus x square. Q is the term on the other side, which is 4x square by 1 plus x square. Now we have to find integrating factor, which is e power integral p dx. So e power integral 2x by 1 plus x square dx. Taking this as t, we get dt in the numerator. So it is e power integral dt by t. So we take t equal to 1 plus x square and dt equal to 2x dx, which is e power log t, and e power log, e and log gets removed, so it becomes t. So integrating factor is 1 plus x square. Now coming to the solution, y into integrating factor equal to integral q into if into dx plus c. So it is y into 1 plus x square equal to integral q is 4x square by 1 plus x square, and again we have 1 plus x square into dx plus c. So q, we copied 4x square by 1 plus x square. Now this gets cancelled, and we can integrate this 4x cube by 3 plus c. This is our solution, and they have given a condition, that is y of 0 equal to 0. It means when x is 0, this is x actually, then y is 0. So when I take x is 0 and y is 0, the entire term equal to 0. So it means c is 0. When c is 0, using that here, we get y into 1 plus x square equal to 4x cube by 3. This is our solution. We can leave like this, or we can carry this term to the other side. So 4x cube by 3 into 1 plus x square. This is our required solution. Next, question number 33. You have to use integration to find the area of the region enclosed by the curve. This is the parabola which is downward parabola. So we take x-axis, y-axis, and we draw the parabola which is downward like this. So we took parabola like this. Then there's a straight line x is equal to -3, which is actually at -3 we have a line like this, and x is equal to 2. At x is equal to 2 we have a line like this. So, and y equal to 0. So it means the x-axis, this is the y equal to 0. Then this is x is equal to 2, and this is x is equal to -3, and this is the parabola. So the area enclosed by all these things we have to find, which is nothing but this region and this region. So what we can do is, we take the area as integral from -3 to 2 and y dx, but y is minus x square dx. Since the region is below x-axis, we will be getting the answer as negative, so we have to take a modulus, and we work out everything inside the modulus. This integration is minus x cube by 3, and we have to use the limit from -3 to 2, and still we keep taking the modulus. When you put the upper limit, minus and 2 cube, which is 8 by 3, this is the upper limit. When you put lower limit, when you put -3, it will become -27, but already there is a minus, so it is plus 27 by 3, and we have a modulus again. So finally this is minus 35 by 3, so we take positive value 35 by 3, so the required area is 35 by 3 square units. Question number 34, A part, we have to find the integral of this. This is using the partial fraction because we have a factors in the denominator and we have a repeated factors. So we take the partial fraction rule, that is x square plus 1 by x minus 1 whole square into x plus 3 is a by x minus 1 plus b by x minus 1 whole square plus c by x plus 3. When I take LCM, the LCM is x minus 1 whole square into x plus 3. So with this a, we multiply x minus 1 into x plus 3. With b, we multiply x plus 3 alone. With c, we multiply x minus 1 whole square alone. Now equating both the numerators, we get x square plus 1 is a into x minus 1 into x plus 3 plus b into x plus 3 plus c into x minus 1 whole square. Now we have to take some value like x is equal to 1. So we can find b. So this will become 1 plus 1, 2 equal to a becomes 0 because we have x minus 1, c becomes 0. And when I put 1 here, we get 4b. So from this, b is 2 by 4, which is 1 by 2. Now if you take x as minus 3 whole square is 9, that is plus 9, and 9 plus 1, 10, and this becomes 0, this becomes 0. I put minus 3 here, minus 3 minus 1 is minus 4, and a square we get plus 16. So here c is, by reducing it, 10 by 16, which is 5 by 8. Now we compare the coefficient of x square on both the sides. So left hand side we have 1, right hand side it is a plus c. Since we know c, we can substitute here. So 1 is equal to a plus 5 by 8. So a is 1 minus 5 by 8. After taking LCM, 8 minus 5, which is 3. 3 by 8. So we got a. Now we take integral a value by x minus 1 dx. Then b value. The b value is 1 by 2. So integral 1 by 2 by x minus 1 whole square dx. Then c value, which is 5 by 8. Integral 5 by 8 by x plus 3. So all these a, b, c values we substituted in the place where we took the partial fraction rule. So a by b by c by, and we have dx at the end in every term. Now if I integrate this, this is 3 by 8 log mod x minus 1 plus 1 by 2. This integration is minus 1 by x minus 1, and this is 5 by 8 log mod x plus 3, then plus c. This is our final answer. In our part, we have integral 0 to pi by 2 x by sin x plus cos x. We are going to apply P4 for this, which is integral 0 to a f of x dx equal to integral 0 to a f of a minus x dx. So let's take this as I equal to, now when I apply this property, we get 0 to pi by 2, and every x is replaced with pi by 2 minus x. So the numerator pi by 2 minus x, and the denominator sine of pi by 2 minus x plus cos of pi by 2 minus x dx, and now this becomes integral 0 to pi by 2 minus x whole divided by sin pi by 2 minus x becomes cos x, cos pi by 2 x, pi by 2 minus x becomes sin x dx. We take this as 1 and this as 2, and we find both has a common denominator. So we are going to do addition of 1 and 2. So that gives 2i equal to, we take one integral and one denominator, which is sin x plus cos x. We are going to add the numerator in both the cases, which is x plus pi by 2 minus x. So we can cancel this. We left with only pi by 2, and then pi by 2 can be taken outside. So 2i equal to pi by 2 integral 0 to pi by 2. We have dx by sin x plus cos x, and from this we have 2-3 methods to do. The easiest one among all is taking 1 by root 2 as a product here and 1 by root 2 as a product in the denominator, and it is 2i equal to pi by 2 integral 0 to pi by 2. This numerator 1 by root 2 we keep it outside, and the denominator we take 1 by root 2 sin x plus 1 by root 2 cos x. Now I am going to further rewrite the denominator. So 2i equal to pi by 2 root 2 integral 0 to pi by 2 dx by this 1 by root 2 I am going to write it as sin pi by 4, because sin pi by 4 is 1 by root 2. Then sin x. Then this 1 by root 2 I am going to write it as cos pi by 4. So cos pi by 4 into cos x. This is actually cos A cos B plus sin A sin B. So the entire term can be written as cos of A minus B. So finally this can be rewritten as 2i equal to pi by 2 to integral 0 to pi by 2 dx by cos of x minus pi by 4. Now we can take this to the numerator as secant. So we get integration of secant x minus pi by 4 dx. This is pi by 2 root 2 and we have 2i. So finally 2i equal to pi by 2 root 2. This integration is log mod secant x plus tan x. Because integration of secant is log mod secant x plus tan x. Mod close, bracket close, 0 to pi by 2 is our limit. Now 2i equal to pi by 2 root 2. When I use the upper limit, we get log of pi by 2 minus pi by 4 is secant pi by 4 plus tan pi by 4. Then minus, when I use a lower limit, log mod secant, when I put 0, secant of minus pi by 4 is secant pi by 4 only, but tan of minus pi by 4 is minus tan pi by 4. So we completed substitution of the limit. One can take mod or normal bracket. Now this 2 can be taken to the other side. So I equal to pi by 4 root 2. Now log of, this is root 2 plus 1 minus log of root 2 minus 1. It is a log rule. So finally this is pi by 4 root 2 log root 2 plus 1 by root 2 minus 1. If we want, we can multiply the conjugate and simplify further, or we can leave it as it is. Question number 35, we have to find the foot of the perpendicular drawn from the given point. So let us take a small diagram. We have this line which is AB, and there is a point here which we take it as P2, minus 1, 5. To find the foot of the perpendicular, we have to drop this point P to the line which is dropped perpendicular to that. So we take this point as Q. So first thing, we have to find the point Q, that is the foot of the perpendicular. Now equating this line equation AB to K. So we are going to get XYZ in terms of K. X is 10K plus 11. Y is minus 4K minus 2. Z is minus 11K minus 8. So the Q is 10K plus 11, minus 4K minus 2, minus 11K minus 8. Now we have to find dr of the line PQ, which is nothing but the difference. 10K plus 11 minus 2 will be 10K plus 9, minus 4K minus 2, minus 1 plus 1. So we get minus 1, and minus 11K minus 8 minus 5, which is minus 13. The same way, dr of AB, which is 10 minus 4 minus 11. Now they are perpendicular, so we are going to use perpendicular condition. Using the perpendicular condition, which is A1, A2 plus B1, B2 plus C1, C2 equal to 0. So this will become product of this and this, because this is A1, this is A2. So 100K plus 90. Then again we have to multiply this plus 16K plus 4 plus 121K plus 13 into 11. So 13 into 11 is 143. 143, which is equal to 0. Now keeping the K terms here, so 121 and 16 and 100, this will be 7, 3 to 237 K equal to, all these we take to the other side with the minus, 143 and 94. So this is 7, this is 3 and this is 2. So we get k as minus 1. Using that k in this point Q, we are going to get foot of the perpendicular, the coordinate. When k is minus 1 here, 10 into k, which is minus 10, then plus 11, that will be 1. Then when I put minus 1 here, it will become 4. 4 minus 2, which is 2. Then again, when I put minus 1 here, this will become 11. 11 minus 8, it will become 3. Already the point P, which is given in the question, this is 2 minus 1, 5. So this Q is the foot of the perpendicular which we got. Now we have to find the perpendicular distance. The second part of the question, they ask the length of the perpendicular, which is nothing but this distance PQ. So using the distance formula, root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. So totally this is minus 1 whole square, which is 1, 3 square, which is 9, 2 square, which is 4. So totally this is root 14 units. Now coming to section E, case study 1, question number 36. They have given a shop selling electronic items sells smartphones of only 3 reputed companies A, B and C. So the chances of their manufacturing a defective smartphones are 5%. So we have to take that as P of D by A, that is the phone manufactured by company A which is defective is 5 by 100 and P of D by B is 4 by 100 and P of D by C is 2 by 100, and in his inventory he has 25% smartphone from company A, so which is P of A, that will be 25 by 100 and P of B is 35 by 100 and 40% from company C, which is P of C 40 by 100. Now in the first part they ask a person buys a smartphone from this shop, find the probability that it was defective. So they want P of D. P of D by formula it is P of A into P of D by A plus P of B into P of D by B and P of C into P of D by C. Now we substitute 25 by 100 into 5 by 100 plus 35 by 100 into 4 by 100 plus 40 by 100 into 2 by 100. Now totally this is 125 and this is 140 and this is 80 whole divided by 10,000, and we are going to add this 125, 140 and 80. This is 5, 10, 14 and this is 3. So we get 345 by 10,000. We can also reduce by 5 table. So if I reduce, this will become 6 times 30 and again 45 is there. So 9 times. If I reduce by 5 table, this is 2, 0, 0, 0. Now coming to second subdivision, what is the probability that this defective smartphone was manufactured by B? So we have to find P of B by D. By formula, this is P of B into P of d by b in whole divided by p of a into p of d by a plus p of b into p of d by b plus p of c into p of d by c. And this numerator p of b value is 35 by 100 into 4 by 100. So 35 by 100 into 4 by 100, and in the denominator already we had 345 by 10,000. So it's better to take this value because we can cancel all the hundreds and this 10,000 together, and now it is 35 into 4 is 140 by 345. By cancelling with 5 table, 5 2 times 10, again 40 is there, so 8 times 40, so this will be 69, so 28 by 69. Next question number 37, case study 2. They are given 3 students, Neha, Rani and Sam go to the market to purchase the stationery items. Neha buys 4 pens, 3 notepads and 2 erasers. So let us take this as x, y and z and pays 60. So the first is we have to form the equation required and to solve the problem to find the price of each item, and we have to express in the matrix form. So we take the first equation as 4x plus 3y plus 2z equal to 60. In the same way, Rani buys 2 pens, 4 notepads and 6 eraser and pays rupees 90. So the second equation is 2x plus 4y plus 6z equal to 90. Then Sam pays 70 for 6 pens, 2 notepads and 3 erasers. So this is 6x plus 2y plus 3z equal to 70. So this is our first equation, second equation, third equation. So we wrote the equation and we have to express it in the matrix form. So Ax equal to B. So matrix A is 4, 3, 2, 2, 4, 6, 6, 2, 3. Then x, y, z equal to 60, 90, 70. So first part completed. Express it in the matrix form Ax equal to B, because this is our A, this is our x and this is our B. After this, second subdivision, we have to find A determinant. So A determinant will be 4 into 4 3s are 12 minus 12, 6 2s is 12, then minus 3 into 3 2s are 6 minus 6 6 36, plus 2 into 2 2s are 4 minus 6 4s are 24. So this is 0, this is minus 30, so minus 3 into minus 30 plus 2 into this is minus 20, so this one is 90 minus 40, which is 50. So we got determinant A, and confirm if it is possible to find A inverse. So since the determinant A is not equal to 0, it is possible to find A inverse, because you can say A inverse exists since determinant A is not equal to 0. Then third subdivision, find A inverse. If possible, write the formula to find the x. the formula for x is A inverse into B. So we have to find A inverse. For that I have to find all the cofactors. So let's copy the matrix A here, which is actually 4, 3, 2, 2, 4, 6, 4, 3, 2, 2, 4, 6, and 6, 2, 3, 6, 2, 3, 4, 3, 2, 2, 4, 6, 6, 2, 3. Now we have to find all the cofactors. So I am going to find cofactor matrix. So that will be, this is 4 3s are 12, 6 2s are 12, so this is 0. The next one is 6 minus 36, which is minus 30, but again in this position minus will come, so it is plus. Then 4 minus 24, which is minus 20. Then coming to the second row elements, 9 minus 4, which is 5. We have to put minus 5 because we follow the sign convention, plus minus plus, minus plus minus, plus minus plus. Then 12 minus 12, which is 0. Then we have 8 minus 18 minus 10, so it is plus 10. Then this is 18 minus 8, which is 10. Then 24 minus 4, which is 20, so minus 20 I have to put because of sign convention. And the last is 16 minus 6, which is 10. After this, we have to find Rj, which is the transpose of the cofactor matrix. So 0, 30, minus 20, minus 5, 0, 10, 10, minus 20, 10, and we have to find A inverse. By formula it is 1 by A determinant into Rj. So 1 by 50 and Rj is 0, minus 5, 10, 30, 0, minus 20, minus 20, 10 and 10. So we got A inverse. So as per the question, you have to find the A inverse. Suppose if you want to verify whether this is correct, we can find the solution, that is x is 1 by 50 into A inverse into B, because the formula for x is A inverse into B. So 0, minus 5, 10, 30, 0, minus 20, minus 20, 10 and 10 again. And this we have to multiply with the B matrix, which is 60, 90 and 70. Sorry, 60, 90 and 70. So if we try to find the solution, we will come to know whether this A inverse is correct or not. This is 0, minus 450 plus 700. Then 1800, then minus 140, then minus 1200 plus 900 plus 700. So totally this will be, first one is 700 minus 450, so 0, 5, 2. So totally this is 250 by, we have by 50 also outside, so 5. And this one, actually there should be one more 0. So this is 400 by 50, which is 8. This is 1600 minus 1200, which is 400. Again it is 8. So these are the xy Z values. I'll just cross check whether this is right or not by using it in any of the equation. So 4 into 5, 20, 3 into 8, 24, 2 into 8, 16. So this is 0, 1, 4, 5, 6. So first equation is satisfied. It means my A inverse is right and the solution is also right. Anyway, they did not ask solution, but I just find to confirm whether the A inverse is correct. Now in our part, A square minus 8i we have to find. So A square minus 8i we have to find. A square, first I have to write A into A. Just copy A here, 432, 246. 432, 246. Then we have 623. So A inverse, again I have to write A, then only multiplication is easier. 246, 623. So the last equation is 623. Yeah. Then minus 8i. 8i is 800,080,008. This we are going to multiply, taking the row with corresponding elements of each column. So this will be 4, 4, 16, 3 2s are 6, then this is 8. Then move to the next column, 4 3s are 12, again 4 3s are 12, then 4. Again next column, 4 2s are 8, plus 18, plus 3 2s are 6. And coming to the second row, 4 2s are 8, plus 8, plus 36. Then again, coming to the next column, 3 2s are 6, 16 and 12. Then coming to the last column, 4 plus 4 are 24 plus 18. Then coming to the third row, 24 plus 4 plus 18, 18 plus 8 plus 6, then 12 plus 12 plus 9. This whole thing minus of 800,080,008. Now the first one is 16 and this is 14, so 30. This is 12, 12, 24, 28. Then again 18 plus 14, which is 32. Then again this is 16 and 36. So 36 and 16, 2, 1, so 52. Then this is 18 and or 22, 22 and 12. So this is 34. Here 28 and 18. 6, 4. So 46. This is 28 and 18. So again 46. Sorry, it's already calculated. Then this is 18 and 14. This is 12, 2, so 40, sorry, 32. This is 32. So this is 1 and this is 3. Then this is 24 plus 9. So 33. Finally, you have to subtract this 800,080,008. So leading diagonal elements alone will get subtracted. So this is 22, 28, 32, 52. When you subtract, this will become 26, and this is 46, and this is 46, 32, and this becomes 25. A small correction. Here this is 12. So now this becomes 22 plus 12, so 34. Then 34 minus 8, that becomes 26. So this is our required final answer for the a square minus 8i. Now the case study 3, question number 38, they have given a ladder of fixed height h. So this is our h. Is to be placed along the wall such that free to move along the height of the wall. Express the distance y between the wall and the foot. So let us draw the diagram. We take a right angle triangle as per given in the question. This is a wall and this is a foot and this is the ladder, and the ladder height is h and this is y, and height x on the wall, this is x. Express the distance y between the wall and the foot of the ladder in terms of h and the height x on the wall at a certain instant. Also write the expression in terms of h and x for the area of the right angle triangle C. Now this is a right angle triangle, so we have a Pythagoras relation which is x square plus y square equal to h square. It means y is root of h square minus x square. Now we have to express the area in terms of h and x. So area equal to half into base into height. But here the base is y and height is x. They are asking to express the area expressed in terms of h and x for the area. So this y we have to replace. So area is half root of h square minus x square, then x. This is our answer. Then coming to substitution 2, find the derivative of the area with respect to height on the wall. Find its critical point. So we copy this area here. So area equal to half, I take this x here, root of x square minus x square. They are asking to find the derivative of the area with respect to height and find the critical point. So when we find a dash, we keep half outside. We have to follow the product rule. X differentiation is 1 by 2 root h square minus x square into minus 2x plus root of h square minus x square. Differentiation of x is 1. So we found the derivative of a with respect to height, and we have to equate to 0 to get the critical point, and this we have to further simplify. We can cancel these two. Now when I take LCM, which is root of x square minus x square, and here it is, actually there will be x here. Now this is minus x. Sorry, actually this is our x and this is 1. So this is minus x square. Then when I take LCM, this will become x square minus x square. Now this is half into x square minus 2x square by root of x square minus x square. We have to equate this to 0. When I cross multiply, we get x square equal to 2x square. And they are asking to find the critical point. So we are doing with respect to with respect to x. So they are asking to find the derivative of the area with respect to the height on the wall x. So with respect to x, which we have done, then we have to find the critical point. So I have to get x from this. So x is, actually x square is h square by 2, x is h by root 2. So this is the required critical point. Then coming to the next part, show that the area of the right triangle is maximum at the critical point. So we got the derivative, first derivative, and we have to prove maximum. For that I have to find the second derivative, that is a double dash using u by v. So we keep 1 by 2 outside, u dash which is minus 4x, and v will be written as it is minus u, then 1 by 2 root h square minus x square into minus 2x, then whole divided by h square minus x square. And we have to show this is maximum at the critical point. So I have to use x as h by root 2. When I substitute x as h by root 2, this part will become 0. It means the entire term is 0. And now we left with only minus 4 h by root 2 root of h square minus h square by 2, and we have a denominator which is h square minus h square by 2. And anyway these two terms are same, we can cut this root and put root here. So minus 4h by root 2 by this, taking LCM we get root of h square by 2. Anyway this is less than 0, therefore it is maximum. So second derivative less than 0, we get maximum. So we proved the area of the right angle triangle is maximum at the critical point. Now coming to the third subdivision B part, the foot of the ladder whose length is 5 meter. So we took it as y. The foot of the ladder we took it as y, which is 5 meter, is being pulled towards the wall such that the rate of decrease in the distance of y. So dy by dt is 2 meter per second. And since it is decreased, we have to take minus 2. Then what rate is the height of the wall? X is increasing. So it is dx by dt is what they are asking. When the foot of the ladder is 3 meter away from the wall. When the foot of the ladder means it is when y equal to 3. Actually, if the foot of the ladder whose length is 5 meter, they are talking about the ladder length. This is actually h, which we have taken in the starting. Now we are going to find, first we take the equation y square plus x square equal to h square. Now using the y value here, 3 square plus x square equal to 5 square. Solving this we get x is equal to 4 because it's a Pythagoras relation. So 4 meter. Now we take this as a first step. We are going to differentiate. Differentiating 1, 2y dy by dt plus 2x dx by dt. H is constant, so it is 0. Anyway, h is 5, so even if I put 5 square, it is 0. Now, 2 y value, which is given in the question, 3. At the end of the question, they have given when the foot of the ladder is 3 meter away from the wall. So this is 3 into dy by dt plus 2 into x, we found it as 4, and dx by dt. Actually dy by dt is given as minus 2. So in this place we take minus 2 and dx by dt equal to 0, because dx by dt we have to find. Now from this is 3, 2, 3, 6, 6, 2, minus 12 plus 8 into dx by dt equal to 0. So 8 dx by dt equal to 12. So dx by dt is 12 by 8. By cancelling the 4 tables, this is 3 by 2. So finally dx by dt is 3 by 2, which is 1.5 meter per second.